afternoon, students, and welcome to the summer course of Q&I. So let me first introduce myself. Students, I am Sunit Kumar and I am your mathematics teacher. We started with the first chapter, that is real numbers, in the previous class on Thursday, and we'll continue from where we stopped in the previous class. So what did we do in the previous class was we discussed about fundamental theorem of arithmetic, and then we also learned how to find HCF and LCM using prime factorization method. Okay, so let's start the session, students.
Sir,
Yes. Yes,
sir, my
Raghav.
device is not working, so me and Rahul is attending in the same device.
Okay, okay, it's fine. So what you can do is you can write this in the chat as well so that your attendance is also being marked for both of you. Okay, so you can write that two of you are on the same device. So how many students took the diagnostic proficiency diagnostic test on Friday? Can you raise your hand? Students who have taken the proficiency diagnostic test on Friday. Okay, Raghavi has taken. Devi Maya.
Sir, Raghavi
Okay.
has not taken up the diagnostic test. Only me. Only I am taken the diagnostic test.
Okay. Okay. So let's start the class, students. So as I said, we started with real numbers in the previous class. So and what are the prerequisites for today's class is to find the prime factorization of a number, because we learned how to find the prime factorization of a number in the previous class. We also saw how to find the HCF and LCM using prime factorization method. So prerequisite for today's class is you should know how to find HCF and LCM, and you should know how to find the prime factorization of a number, which we had discussed in the previous class. In today's class, what we are going to cover is we are going to do few more problems on HCF and LCM so that you get a hands-on experience of this concept. And then we are going to do some word problem, that is application of HCF and LCM in day-to-day life. Okay, so this is the agenda for today's class, students. Let us start with a question. So we had already done some questions in the previous class where we had to find the prime factorization of numbers. In today's class, student, we'll find the HCF and LCM using prime factorization method. So first of all, we'll start with the first question, that is, finding the HCF and LCM. Okay. So finding the HCF and LCM of 26 and 91. So first of all, what we do is step one, we will find the prime factorization of 26 here. So if you do a prime factorization of 26, this is 2 times 1 into 13 times 1. So it is easy, so we can directly write it. Otherwise, you do the prime factorization with the smallest prime number first. And then 91 can be written as 7 to the power 1 into 13 to the power 1. Right? So once you have done the prime factorization, we know that HCF, how do you find an HCF? HCF is find the common factors and the smallest power of that common factor. So the common factor we can see is 13, right? And the smallest power is 1. So HCF is 13 to the power 1, which is equal to 13 here. And LCM, in case of LCM, what we do, we find all the factors here and the highest power of that. So highest power, all the factor, what are the factors? Prime factors, 2, 7 and 13. Highest power of 2 is 1, 7 is 1 and 13 is 1. So LCM will be 2 to the power 1, 7 to the power 1 into 13 to the power 1. So if you calculate this, 13 sevens are 91 into 2 is equal to 182. Okay. So LCM is 182 and HCF is 13. Very good. Very good, Raghavi. Is this concept clear to everyone? Is this method clear to everyone? So you would have this question would have revised your previous lectures concept. Okay. So this is the first part. Okay, very good. So Raghavi, Alan, and Devi Maya, all three of you have understood this? And who is there with Raghavi? I missed out your name. Can you please write it in the chat? I missed out your name. Okay. So what I'll do, okay, Ragul. So I'll just, rub this. I hope everyone has noted this down. So can you do this second question? You have to find the HCF of 510 and 92 and also the LCM of 510 and 92. Please attempt this second question. 510 and 92. So I'll do it together with you. So we'll write the prime factorization of 510. So if I divide it by 2, this is 255. Then by 3, 85. Then by 5, 17. And by 17, 1. So 510 can be written as 2 to the power 1, 3 to the power 1, 5 to the power 1 into 17 to the power 1. Now if you do a prime factorization of 92, yes, Raghul, it is correct. Raghavi and Raghul, HCF is 2. So when you divide it by 2, you have 46. Divided by 2, you have 23. Divided by 23, you have 1. So here we have 2 square into 23 raised to the power 1. Now, if you have to find the HCF, the common factor is 2 and the lowest power here in 2 is 1. So HCF is 2 to the power 1, which is 2. And if you have to find the LCM, you have to write all the factors and its highest power. So factor 2 has a highest power of 2, 3 to the power 1, 5 to the power 1, 17 to the power 1, and 23 to the power 1. Okay. So if you calculate this, right? So we have 4 into 3 and then into 5 into 17 into 23. If you calculate this all, you will get 23460. So this is the LCM 23460. In this question, you also had to verify in both all the parts that LCM into HCF is the product of two numbers. Let's verify it here. So product of numbers. So product of two numbers, that means you have 510 into 92. Okay. So 510 into 92, this will be 46920. And if you have to find HCF into LCM, this is 2 into 23460. So if you multiply 2 with 23460, you will have 46920. Okay. So you can see that since let's say this is your LHS and this is your RHS. So since LHS is equal to RHS, hence this is verified. Clear, students? Yes, Raghavi and Raghul, very good. Is it clear to everyone? Has everyone understood this concept? You have understood it, right? Alan, you have also understood it? Okay. Okay, good, good. Let's go to the next one. 336 and 54. Can you quickly tell me the HCF and LCM of this? 336 and 54. I'll rub this. I hope everyone has written this down. So you have to find the HCF of the third part and also the LCM, and then you have to verify as well. So first find the HCF of 336 and 54, and then the LCM. To find the prime factorization of 336. HCF is 6. Yes, correct. Raghavi and Ragul. When you divide it by 2, right? 168, then by 2, 84, 242, 221, 37, and 71. Right? So 336 can be written as 2 to the power 4, 3 to the power 1, and 7 to the power 1. And 54, if you find the prime factorization of 54, 2 times 27, 3 times 9, 3 times 3, and 3 times 1. So 2 to the power 1 and 3 to the power 3. If you have to find the HCF, you have to take the common factor. Common factor is 2. Yes, LCM is also correct. Please verify it as well. So in HCF, you see the common factor is 2 and 3, and the lowest power is 1 in both the case. So 2 to the power 1, 3 to the power 1 is 6. LCM, we have to take all the factors with highest power. So 2 to the power 4, 3 to the power 3, and 7 to the power 1. So if you have to calculate this, we know that this is 16 into 27 into 7. So 16 times 27 into 7 will give you 3024. So 3024 is the LCM. Now we have to verify it as well. So that means HCF into LCM will be equal to 6 times 3024. So if you calculate 6 times 3024, this is 18144. And if you have to find your product of two numbers, so product of two numbers is 336 into 54. So if you calculate this, you will have again 18144. So since LHS is equal to RHS, hence this is verified. Very good. Very good, Devi Maya, and very good, Raghavi and Ragul. Is this clear, students? Have you understood it? Have you understood the concept of HCF and LCM? Okay, let's quickly go to the next now. So in the next question, let's do one and the rest two can be your homework. One, you can do it here only, one along with me and one as homework. Okay, so let's do the first question. We have to find the LCM and HCF of the following integers by applying the prime factorization method. So 12 can be written as 2 to the power 2 into 3 to the power 1. 15 can be written as 3 to the power 1 into 5 to the power 1. Okay. And 21 can be written as 3 to the power 1, 7 to the power 1. Now, if you have to find the HCF, the common factor is 3 only and power 1. So HCF is 3. If you have to find LCM, the factors are 2 square, 3, 1, 5, 1, and 7, 1. So 4 3s are 12, 5s are 60 into 7. That is equal to 420. So 420 is your LCM. Very good, Raghavi and Ragul. So HCF is 3 and LCM is 420. Now, if you want to check whether that formula is valid for three numbers, you will find that 12 into 15 into 21 is something else, and HCF into LCM will give you something else. Let's check it. 12 into 15 into 21 is 3780 if you multiply all of this. And if you multiply HCF and LCM, we have 420 into 3. This is 1260. So these are not same. So that's why that formula, as we said, it is not valid for three numbers. It is valid only for two numbers. Okay. Is it clear, students? Can you quickly find the HCF and LCM of 8, 9, and 25 as well? Find the HCF and LCM of 8, 9, 25. Yes, very good. HCF is 1 because there is no factor in common. Okay. So the HCF will be 1 when there is no factor common. LCM, product of all three. 2 cube, 3 square, 5 square. Right? 2 cube is 8. 3 square is 9. So 8 into 9 is 72. You multiply 25 to it. So 1800 is your LCM. Yes, very good. Is it clear? In this second case also the same thing. There is no factor in common because 17, 23 and 29 are all three prime numbers. So HCF will be 1 and the product will be the product of these 17, 23 and 29. So in case of the second one, your HCF is 1. You can calculate it later. And LCM, we know, is product of all this. So 17 into 23 into 29 will be 11339. So this is 11339. Is it clear, students? Have you understood the concept? Okay. Let's go to the next question, students. Now, in this question, it is easy because HCF is already given and you have to find the LCM and the two numbers are also given there. So it is always easier to use the formula here. So the formula says that HCF into LCM is equal to product of two numbers A and B, for example. So HCF is given as 9 times LCM and the product is 306 into 657. So your LCM is 306 into 657 by 9. So if you cancel this, 9 3s are 27 and then 36, 9 4s are 36. So 34 into 657 you have to calculate. So 34 into 657 is 22338. So your LCM here is 22338. Is it clear? Is it clear, everyone? You have understood? Okay. So let's go to the next question. Have you noted this down? Okay, let's move to the next question. Now the next question is, this we had already done when we were doing 4 raised to the power n. The example which is there in your NCERT. Check whether 4 raised to the power n can end with the digit 0 for any natural number n. So here we have to check whether 6 raised to the power n can end with digit 0. Will it end with digit 0? And if yes, then why? And if not yes, then why not? It will not end with 0. Good. Why will it not end with 0? Yes. So there is no factor of 5 and that's why it will not end with 0. For a number to end with 0, it should have at least one factor of 2 and one factor of 5. Why? Because 10 can be only made by 2 into 5. Right? So in prime factorization, you should have at least one power of 2 and one power of 5 for a number to end with 0. So 6 raised to the power n can be written as 2 into 3 raised to the power n, which is 2 to the power n into 3 to the power n. Right? Now, if you expand this, you will have 2 coming n times and 3 coming n times. There is no factor of 5 here. So for a number to end with 0, it should have 2 and 5 as prime factors, right? But 6 to the power n does not have 5 as prime factor. Hence, 6 to the power n will not end with 0. Is it clear? Students, is it clear? Okay, good. Let's go to the next now. So this is similar to the question which is there, in the NCERT example, and this is the question from NCERT exercise basically. So we are trying to do the first exercise right now. Let's move ahead, students. Now the next question, explain why 7 into, so we'll take it one by one. You have to first explain why 7 into 11 into 13 plus of 13 is a composite number. Who is going to tell me? Why is this number 7 into 6 into 7 into 11 into 13 plus of 13 a composite number? Raghavi, Ragul, Devi Maya and Ellen. Anyone?
So
Yes.
So we should take common factor in the first case. If we take common factor inside the bracket, we would get 7 into 11 plus 1. So 7 into 11, 77 plus 1 would be 78. So if you 13 is a prime number, but 78 you can express it in the form of 2 into 3 into 13. So it has more than 2 factors.
So it's a composite number.
Yeah, it is a composite number, and I'll tell you. The thing which you explained was an elaborate explanation. But yeah, before that also you can say, what are prime numbers? Let's understand the definition of a prime number. Prime numbers are those numbers which has only two factors, one and the number itself. Right? Now, in this 7 into 11 into 13 plus 13, if you take 13 as common, you have 7 into 11 plus of 1. Right? Now, here, this is 13 into 78, right? So this number, students, have two factors, right? And many more factors, obviously. But since it has more than two factors, one, the number itself, other than that, you have 13, and then 78 will have further factors, right? So these are factors which are more than one and the number itself. Now, since this number has factors more than 2, that's why it is not prime and it is composite. Clear? Is it clear to everyone? Okay. Now similarly here also you will write that 7 into 6 into 5 into 4 into 3 into 2 into 1. plus of 5. Now this has 5 in both these parts. So if you take 5 as common, you have 7 into 6 into 4 into 3 into 2 into 1 plus 1. Now this is one factor, this is another factor. Other than 1 in the number itself, you have 2 more factors and many more factors, in fact. So that's why we say that this number is also composite. So in statement, you will write that since these numbers have more than 2 factors, 1 and the number itself, that's why it is not prime, it is composite. I'll write it here. Since these numbers have more than 2 factors, hence they are not prime. Okay. They are not prime, but composite numbers. Is it clear? Have you understood, students? Okay, let's go ahead. Now the next question, this is an application of it, it's prime factorization, HCF, LCM. So let's, now the questions which are going to come, these are application based questions. So let's understand this question, which is again from your NCERT. So the question is, there is a circular path around a sports field. So you have a circular path which is around a sports field. Sonia takes 18 minutes to drive one round of the field. So let's say Sonia, she starts and she covers this whole distance, right? So she covers this whole distance in how much time? 18 minutes. Okay. Now, while Ravi takes 12 minutes for the same. So Ravi is faster and he takes 12 minutes to complete this round. Right? So by the time Ravi has completed one round, Sonia is still somewhere in between. Okay. Now, after how many minutes will they meet again at the starting point? So, and they are moving in the same direction. And they have both started at the same point and same time. Both start with this point at the same time. So you have to tell me, how are you going to find that how many minutes will they, in which they will meet at the starting point again? How do you find this? You just need to let me know the concept and why. Students, there is a feedback form. You can fill the feedback form after the class. Okay. It is there in the chat. Yeah, tell me why, means how to find the answer to this question and why are we using that concept? Both. Anyone? You can unmute yourself and let me know. Okay, let me tell you. Yes, you have to find the LCM. Why? Raghavi or Ragul, whosoever is writing this.
Minimum after how many minutes they will meet again at this starting point. So the word minimum means which is less, which means LCM.
Yeah, this is one way of finding it. There is one more way of finding it. Now the time which you are going to calculate, students, this is going to be, see, if Ravi takes 12 minutes and Sonia takes 18 minutes, that means, the time at which they'll meet again at the starting point will be more than both 12 minutes and 18 minutes. This is clear? So a number which is greater than 12 and 18 cannot be a factor. It will be a multiple only, right? So, whenever you find an LCM of two numbers, this is greater and equal to both the numbers. And the HCF is, less than or equal to both the numbers. So either HCF will be less than both the numbers or will be equal to any of these smaller numbers. One of the smaller numbers. And LCM will be either greater than both the numbers or equal to the larger number. So this concept, if you keep it in mind, you will be able to solve all these word problems very easily. Okay. So, and there is one more, the concept which you discussed when they say that how many minutes will they meet again? Now this is going to be a multiple, again when they are going to meet. And you have to find, the minimum time at which this happens, right? So because it is minimum when they'll meet again, and that's why we are finding least common multiple. Okay. So let's find the answer to it. Yes, Raghavi and Ragul, you are correct. So we have to find LCM of 18 and 12. So 18 is 2 to the power 1, 3 to the power 2, and 12 is 2 to the power 2 into 3 to the power 1. So if you find the LCM, this is all the powers with highest powers, all the factors with highest power, 2 square, 3 square. So this is 4 into 9, which is equal to 36 minutes. So after 36 minutes, what will happen? Sonia will cover 2 rounds and Ravi would have covered 3 rounds by then. And they'll meet at the starting point again. Is it clear? Is this concept also clear, which I was discussing, that why we are going to find the HCF and why we are going to find the LCM? Okay. Great. Now let's go to the next. You have to answer this, right? So if P and Q are two distinct prime numbers, then their HCF is, if these are two distinct prime numbers, what will be the HCF? These are MCQ questions, so you need to answer fast. Yes, Devi Maya and Raghavi, Ragul, very good. Ellen is also going to answer now. Right? So it is option D, 1. Why? Because they are distinct prime numbers. And we know that there is no factor in common between two prime numbers, because prime numbers have only two factors, one in the number itself. And because these are two distinct prime numbers, they will have no factor in common other than 1. And that's why the HCF is 1. Very good. Next. If P and Q are two distinct prime numbers, then LCM of P and Q, you have to find the LCM of P and Q when P and Q are two distinct prime numbers. What is the LCM when you find the, LCM of numbers which are two distinct prime numbers? Yes, Ellen, Devi, Maya, Raghavi, Ragul, very good. It is PQ. When you have no factors in common, when you find the LCM, it will be a product of both the numbers, that is PQ. Okay. Now students, you need to tell me how many of you have taken this diagnostic test, the proficiency diagnostic test. How many of you have taken this test? There is only one student, I suppose, who has taken. So the students who have not taken the test, please write your name in the chat box, so that, before you start practicing on the platform, you need to take that test so that platform understands and tells you that, because it is AI based, it will tell you what are your strength areas, opportunity, hurdle, and weakness areas. And then accordingly, when you come to practice, the platform will give you questions of that level where your understanding is currently. Okay, so that's why it is very important that you take that diagnostic test. Please write your name. Devi Maya, you have not been able to. Raghul, you have not been able to, and Alan has also not been able to. So
Sorry, sir.
please,
Sorry, sir. Sir, I have take the diagnostic test, sir.
okay,
Raghavi
Raghavi
haven't
has
take the
not taken. Okay, Raghavi hasn't taken a test, so Raghavi needs to take the test. Okay, now what the because Raghul has only taken, and then I'll tell it to everyone as well. So what you need to do, you need to practice on the platform from today. So I'll tell you the topic which you have to practice as homework today. So go on this. When you log in, you will get to dashboard. You have to go to this, assessments, practice, and then custom practice. So in mathematics, you have to come down to the chapter which we are doing right now. So we have done real numbers, right? So you will see the view topics here. So when you expand this real number thing, you will have these topics, right? So this third topic, explain the process of calculation of HCF using prime factorization. This is what you have to do today, students. Okay.
Sir,
So
can you please share this link in the chat box?
can you come again?
Sir, can you please share this link in chat box?
The link in the chat box. Link you already have the test thing. I'll share you, but you will have to log in first. Okay. So I'll put it in the chat box, but you will have to log in first. Right. Once you log in with your login ID and password, you have to go and practice here. I've shared it in the chat box. Okay. Name of the topic which you have to practice today is explain the process of calculation of HCF using prime factorization. So you will get questions based on finding HCF and LCM using prime factorization. Clear? Is it clear, students? So you need to register first. So for registration, there was a form which was being circulated to you guys. Okay. So Devi Maya and Raghavi and Alan, I'll ask the customer support team to give you a call today on your registered number, the number which you have shared for registration, and then they'll guide you on how to log in on the platform and how to take the test. Clear? Okay, student. So thanks for joining in today. So we'll end the session today here. And in the next class, when we meet, we'll discuss few more questions on finding HCF and LCM, maybe a couple of more word problems. And then we can start with irrational numbers. Okay. So thank you, students. Thanks for joining in. Bye and take care. Have a very nice day.